Hello, everyone. Thank you so much for joining us for another webinar here on Food Industry Executive. We're super excited to have you all here today. We will be hearing from Dassault Systems in their presentation for Virtual Twin for simulation-driven packaging design for food and beverage. Before we get started, I do have just a couple of housekeeping items to go over. First, if you have any questions at all during the presentation, go ahead and drop those into the questions panel in Zoom, and we'll address them at the end of the broadcast. Second, we will be sending out this recording after the event, so be sure to keep an eye out for that. But without further ado, I am pleased to introduce today's presenters, Cole Sampu and Zachary Strickland. Cole is a Dassault Systems client executive. He uses his engineering background and analytical skills to drive transformations across the CPG industry. Zach is a Simulia senior client representative. Zach has a mechanical engineering background and 11 years in the design and manufacturing industry. Zach joined Dassault in early 2022 with a focus on helping CPG-R and H&L companies recognize the value of simulation-driven design by leveraging the virtual twin. So today, Cole is going to start us off by discussing packaging design challenges, and then Zach will provide us with an overview of simulation for packaging design, illustrated by several demos. The webinar will wrap up with some comments on packaging sustainability and a discussion of several customer cases. So let's get into the presentation.
So when a CPG customer is making the product decision at the shelf, packaging is the first thing they see. Studies show that in-store, consumers take just 13 seconds to make a decision on which product to go with. Packaging is the forefront of the consumer's decision on whether or not to buy the product and delivers brands into the consumer's hands like nothing else can. When bundling in how important it is to capture the attention of the consumer at the shelf with how quickly they make decisions, it becomes clear how important it is for successful CPG companies to have the ability to create packaging that will drive interest in their consumers and meet their demands of functionality, design, and sustainability, all while keeping up with their constantly changing needs. The end result, the package, is real and is tangible. While trying to address the package development process, CPG companies often run into some challenges. First, we see inefficient collaboration. More often than not, the package development process consists of siloed departments with a linear development process. You have designers working on new packaging without fully understanding how it will perform. To understand how it will perform, there is often time-consuming and costly analysis done late in the design cycle. Oftentimes, rework is required, and this process repeats until time runs out or is considered good enough. Shortening time to market. This goes hand in hand with inefficient collaboration. CPG businesses are under pressure to decrease the time it takes to get to market with a product that's going to perform well. This is critical for them to establish a competitive advantage and secure better margins during the course of a product's lifetime. A shorter time to market can only be achieved by accelerating innovation, shortening design life cycles, and embracing collaboration in an effort to streamline package design and product launch. With an ever-changing economy, profit pressures and cost containment become relevant. Every CPG business has goals to reduce direct material costs, reduce rework, reduce physical tests, and eliminate product recalls in an effort to decrease the cost, create and increase margin without changing the cost of the consumer. And finally, sustainability. Sustainability is top of mind, being broadcast to investors with ambitious goals to use more environmentally friendly materials and meet different metrics that will ultimately make products more sustainable. Saving a few grams from a package can translate into tons of prevented plastic pollution and energy reduction to create and ship a product. With all these challenges considered, there is an alarming level of new product introduction failures in the CPG industry. Over 80% of new products fail to meet their financial or market attainment goals within the first year. When it comes to package development, we often see this typical business process, starting with the collection of market insights. Those insights then turn into a formal project and begin to develop the product and packaging. After a certain level of confidence is gained, the team moves to physical prototyping and testing, usually starting to develop the artwork so that the stakeholders can help visualize the product once some final revisions are decided upon. Once businesses go through this cycle a few times, they get the specifications created and the manufacturing definition completed. Now, what if you could perform all of this virtually? Through capabilities like automating the design process, incorporating sustainability as an early design KPI, while at the same time capturing manufacturing transformations within the context of the model, CPG companies can reduce physical prototyping by 50%, while at the same time reducing design time, reducing material costs, testing costs, and reducing quality costs. Now, we call this concept the virtual twin of package. The virtual twin of the package allows customers to innovate faster while lowering costs associated with material and testing and with higher quality.
Thanks, Cole. So here we've put together a short video to showcase the virtual twin of packaging and how simulation can be used to help streamline the development process. 5 to 8 seconds is how long it takes for a consumer to make a buying decision at the shelf. Millions of dollars are spent on package design to capture the consumer's mind for those 5 to 8 seconds. And yet, 50% of the packaging initiatives fail. Realistic simulation helps in developing innovative packaging faster, with less material, and can remove the need for physical prototyping, which costs tens of thousands of dollars. With our advanced nonlinear solver tools, you can accurately predict the package strength and stability, not only of the rigid packages, but also simulate to check the integrity of flexible packages during filling and dropping in an easy-to-use drag-and-drop type environment. Here's an example of a bottle squeeze and a drop test with easy-to-understand visual results, along with your standard reporting. Flexible pouches are a good example of how we can turn a challenging problem into a standardized workflow to better understand how a new design will perform when filling and dropping to ensure that the desired performance characteristics are met. We also have the ability to accurately model cardboards and realistically predict the deformation of a cardboard under various loads using a unified design and simulation environment. The examples that you've seen here are just a few of the ways that we're able to help accelerate design time, optimize package design, and reduce package weight, all while providing accurate package simulations to help companies better understand how their product will perform before ever creating a physical sample. If you remember a few slides back, Cole talked about inefficient collaboration being one of the primary challenges. Oftentimes, businesses have a design group that takes a concept and develops what they believe to be the perfect package based on their experience and legacy knowledge. Depending on how mature the prototyping process is, a 3D CAD model or physical sample is created. This is then passed to a team to validate that design meets certain KPIs and performance characteristics. We think of this fragmented process as throwing it over the wall. Although this fragmented workflow creates many challenges, the one we hear most often is that it takes the design team many weeks to get any type of reliable feedback on how the package performed. This process typically repeats several times until the team is happy with the design or until time runs out. By bringing simulation up front and putting the tools in the hands of the designer, the team is able to run through tens or hundreds of designs and get tangible results in hours instead of weeks. You may be thinking, this type of work requires a specialist or an analyst, and you would have been correct in the not so distant past. This is the most significant area that we've improved in. We're now able to capture best practices and standards to create a drag and drop type template or application on the 3D Experience platform. This enables the design team to automate design analysis or run through a design of experiments and allows the software to identify the top package design based on business-defined KPIs. By implementing these tools, we're not saying that final validation shouldn't be done. In fact, we believe a final validation should still be done. The idea is that because of the virtual testing, you will know the answers before investing the time and money in a final validation. This results in fewer prototypes, less iterations, and smarter testing. The virtual twin and virtual testing environment helps save months in the product design process, which ultimately helps get product to market faster. What's great is that everything needed to implement this can be found on the 3D Experience platform on the cloud, which makes it easy to scale and implement. So, to see what this looks like, let's first start off by looking at a typical end-to-end packaging development process for a new package initiative. If it's a minor refresh for an existing package, we can skip most of these steps and move forward to the mass production. But in the case of a new innovative packaging initiative, it starts with package ideation, where the industrial design team group starts with a rough package sketch that in most cases will get converted into a 3D CAD model. Once you have a 3D design, sample bottles are manufactured and sent off for physical testing. If the tests are successful, the package goes into mass production. In most cases, there will need to be some type of rework, and it'll go back to the drawing board where you can make these changes, which requires this loop to repeat. Repeating this loop is not ideal. Some of the drawbacks include: 1, it is a time-consuming process to repeat all these steps. 2, it's an expensive process to manufacture and test sample packages. And 3, failed tests delay the time to market goals, which in turn result in lost revenue. Lastly, physical tests provide limited insights into the cause for failure. And if you don't know why it's failing, you can't easily correct the root cause. On the 3D Experience platform, integrated modeling and simulation becomes rather easy for the engineers to test their package design in a virtual setting to gain insights on how the package will perform. Again, the great thing about this is that it's all done before even ever manufacturing the first sample of the package. It also allows a designer or an engineer to gain knowledge on how the package will perform in real-world settings using virtual simulation. There are many advantages of including a modeling and simulation approach in the packaging development process, such as 1, reduce costs by reducing physical testing. 2, detecting design issues early by analyzing multiple designs, which in turn accelerates time to market and also provides valuable insights on why the package failed. 3, it helps to improve overall package and performance. And lastly, it reduces the package related recalls that you can see late stage. The great thing is that the platform can be used not only to assess the performance of primary packages, but also perform stability analysis on secondary packages and pallet level simulations on tertiary packages to see how a pallet will withstand transportation scenarios when transported from one place to another. I've touched a little on how the modeling and simulation tools can help a designer automatically identify the best designs that meet your packaging requirements. So what you're seeing now is the design space checking the different designs across a large number of possible combinations to assess what's going to perform best. Just like most everything on the 3D Experience platform, this type of study can be run leveraging an on-premise HPC, or for simplicity, it can be run on the cloud for optimized performance. What's nice is that as the study progresses, you can actually monitor and assess the results in real time. Designs that don't meet your requirements can automatically be eliminated so that the designers and engineers are only considering the top designs. The best design is then automatically selected, and the remaining designs are ranked against different performance objectives. And what that does is that helps a designer weigh the trade-offs and understand where there's room to give and take during the design process. So here, the user has now selected the best bottle design in the 3D Experience platform, where it can then move on to the next stage of the design cycle. This information has all the traceability needed and is available in the collaborative environment for other users to access. The same concept that's applied to primary packaging can also be applied to pallet level simulations for tertiary packaging. We can now look at a workflow spanning from packaging design to transportation validation. We can start from a primary package design that we discussed earlier and take that into a secondary package, which leads into the design of the pallet. Once the designs are completed, we're able to conduct virtual simulations such as stacking and shipping tests to detect risk much earlier on. If needed, we can adjust the secondary package design, which will automatically update the pallet design accordingly. So this video here is going to show you how you can easily create a secondary package from the primary package and optimize the way in which the primary packages are filled in the secondary pack. So here you can see they're going through a process to see which orientation is going to work best for the bottle. And then once that's done, you're able to create an appropriate pallet pattern for the secondary package. And you have the flexibility to try different pallet designs and select the one that's best suited for the business requirements. And remember, all the secondary package and pallet designs are made of an actual 3D CAD model, and we can directly use the created pallet pattern in the simulation. Design optimization by simulation takes into account static loading, stability simulation, and dynamic simulations. Best mathematical solution gives results about how to pack the most amount of goods in limited space. Using simulation, we can validate and obtain optimized solutions between mathematical and physical solutions. The old method for tertiary packaging provides no predictive capabilities, whereas here on the 3D Experience platform, we're able to automatically score and down select the best designs based on probability of success. The old method is a very manual process where individual engineers' judgment and experience plays a huge role in the down selection. Here, the 3D Experience provides models based on historical performance of like designs or different designs with similar variable parameters, so you have a high level of confidence before verifying your design.
Incorporating sustainability as a KPI to hit in the early phases of the design cycle is critical to effectively tracking and progressing towards sustainability goals. This is made possible through eco-design. Eco-designing allows the designer to look at the solution with a holistic mindset. Material selection is critical in the performance of the package, but it's also impact on the environment. Is it reusable? Is it recyclable? Designers need to think the entire life cycle and not just specific areas of it. And now, a precise eco-footprint can be calculated as part of the design criteria by using the structure of the package and sustainable parameters of the materials used. When it comes to the sustainability of a package, 80% of environmental impact is determined early in the initial design stages. Now let's look at how this is done with state-of-the-art LCA or lifecycle assessment for packaging. The product environmental footprint is a lifecycle assessment-based method to quantify the environmental impacts of products. CO2 emissions, for example, can be modeled, and we can compare multiple differing designs. By modeling the human activity impact of the materials used in the packaging, you can see the analysis of land used, water used, CO2, GHG, and overall eco scores. The LCA tool also provides comparison analytics to highlight which areas exceed our design thresholds. So now, we can not only model and simulate the performance of packaging strength, but also have the estimations of the environmental impact before we produce one physical prototype. Let's jump into some customer cases. showcasing how the virtual twin is being used in CPG companies today. The first example customer cases is the R-Dog Group. Three industry leaders in sustainable solutions for glass industry are coming together to collaborate on innovative technology to increase the strength and thereby significantly reduce the weight of glass bottles. Dassault Systems, the R-Dog Group, and Exergy will begin virtual twin trials on Diageo's iconic Johnnie Walker bottle. The project kicked off to research and develop a new external coating for the glass bottle to reduce the micro cracks in the glass surface, which will allow the glass bottle to be much lighter while maintaining its strength. The lightweight glass bottle will maintain 100% recyclability, and if successful in the virtual trial, will undergo glass bottle testing. By using the virtual twin, the time and cost needed to test glass products will reduce, while also reducing the raw materials and energy used in that costly testing process. A virtual twin is a real-time digital representation of a product or process that is used to model, visualize, and predict new innovations before any physical trials take place. Another CPG example we'll cover is PepsiCo. At PepsiCo, consistently driving towards a circular economy as a leader in consumer packaged goods. And when addressing the sustainability of their packaging, they were initially challenged by bridging the gap between sustainable packaging solutions and the structural integrity of the pack in order to survive the shipment and shelf stability of the products. The solution? By using realistic multi-physics simulation technology powered by the 3D Experience platform, PepsiCo was able to virtually test package concepts by using virtual first principles. They evaluated products before conducting any physical trials. And what this led to was in-house democratized simulation capabilities that reduced beverage packaging development time and cost savings millions of dollars per year, and increasing productivity efficiency improvements of 30%. The third CPG case we'll cover is with Unilever. At Unilever, sustainability is at the core of their vision and purpose. And when it comes to product and packaging development, optimizing the use of materials plays a huge role in that purpose. To help drive towards that purpose and vision, Unilever implemented Dassault Systems ModSim technology within its package development processes. ModSim, modeling and simulation, unlocks the ability to democratize simulation capabilities that would generally require a simulation expert to run, down to the designers and packaging engineers. Unilever uses this to test materials before physical prototyping and for virtual lightweighting of their package designs. And what this has given Unilever is an average weight savings of 12% across their packaging through optimized designs, as well as the ability to reduce the use of material that negatively impacts sustainability and cost of goods.
All right, thank you so much. And with that, we are going to hop into the Q&A portion. So if you do have any questions for the presenters, be sure to pop those into the Q&A panel here. So first one we have for you, Cole and Zach, is does the simulation capability only integrate with Dassault Systems CAD software?
Zach, I can handle this one. Thanks for the question, guys, and also thanks again for attending. So while CATIA and SolidWorks have integrated applications on the 3D Experience platform, for the ModSim workflow, we can work with any 3D CAD solution. We found this capability helpful for companies who design in-house with one or a few type of CAD solutions for internal design, but a lot of CPG companies we work with suppliers or in-house jointly. And so having that ability to pull in any design tool gives them freedom to choose what direction they want to move in.
All right, thank you so much. Second one here is, do we need simulation expertise in-house for this workflow?
Yeah, I can take this one, Cole. The short answer is no, right? Basically what we're doing is we're capturing the workflows and putting those into a templatized form so that anyone on the team can leverage this technology to get the results and KPIs that they need to kind of make those design decisions. And these templates can be created in-house if you do have an FEA expert, or this is something that DASO can assist you with.
Okay, and next question here we have is, how does the LCA tool fit into the ModSim workflow?
That's a good question. So using the LCA tool alongside ModSim workflow will give you a holistic understanding on how design changes impact all of the KPIs associated with the pack. Using both when comparing designs and materials, you'll be able to optimize your design and material choice by finding a package that meets both your structural needs and hits your sustainability goals as well.
Perfect. And it looks like we have one more for you here, and that is, how long does it take to get the solution up and running?
So it varies. If you're working on the cloud, it's a pretty easy process. We create a tenant for you and you're up and running within 24 hours. If it's an on-premise solution, then we would work with your IT team to configure the solution. But regardless, in most cases, we're up and running within a day or so.
All right, thank you so much. That is all that we have for you today. So I just want to thank all of you so much for attending today. And of course, thank you, Zach and Cole, for the excellent presentation. Everybody can keep an eye on their inbox for a recording after the event. And everyone, have a great rest of your day. Thanks so much again.
Yeah, thanks everyone. Thanks, Hillary.
Thank you.
Cole.